Hi team, we're finally ready for exponential and logarithmic models. So let's review a couple of things and a couple of new definitions. Recall exponential growth function is given by the equation capital A of t equals little a times e to the RT, where a is still the initial amount when your time is 0, and r is the growth or decay factor. And remember, if they tell us that it is continuous growth or decay, that's when we use the E. Now, for definition 2, this is called doubling time, and that's how much time it takes for a quantity to double in size. For example, if we have our generic equation A times E to the RT, our ending amount is going to be twice that of our initial amount. Okay, so 2A equals A times E to the RT. Our next definition is what we call half-life. And this is the time it takes for the substance to exponentially decay to half of whatever the original quantity was. So again, if we start with A times E to the RT, where A is our initial amount, our ending amount would be 1/2 times A. Now, sometimes the problems give us the starting amount, A. Sometimes they do not. And that's okay. We could just plug in a generic A, because notice the two A's will divide out. Or you could just plug in any number like 100. So if it's a half-life, it would equal 50. If it's a double life, it would equal 200. They will all work out the same. So that's the nice part about doubling time and half-life, is you don't even have to know the initial amount. So let's try example 1. We have the half-life. Okay, so that's important. We've got a half-life of a carbon-10 is 19.225 seconds. And then it asks us a couple of questions. First, it says if a researcher possesses a 100-gram sample of carbon-10, determine an equation for the amount A in grams of carbon-10 after t seconds. Well, if we're dealing with half-life, they're wanting this equation, A of t equals A times E to the RT. Anytime they mention doubling time or half-life, we know we're talking about continuous growth or decay. When they're asking you to come up with an equation, there are only two variables that remain. This guy here, our output, and our t, which is our input. Well, they gave us the A, they gave us the initial amount, which is 100 grams. The only other variable, remember E is a number, the only other variable they did not give us is R. That's what we have to find in order to come up with this equation. Well, they did give us a half-life. So this is kind of like giving us a point to help us find a y-intercept or a slope. If our t is 19.225, then our A of 19.225 would be half of 100, or 50. Okay, so they gave us enough information to plug in every variable in order to solve for our R. So we have to do that first. So we know for the half-life, we will end up with 50 grams if our initial amount is 100 grams times E to the R times 19.225. Our R is in the exponent position, so we have an exponential function we're trying to solve for. So we need to get that base, that E to the 19.225 R by itself. So we're going to divide both sides by 100, and that would give us 0.5 equals E to the, I'll go ahead and put 19.225 R. Your motivation here is trying to get that R by itself, but the R is in the exponent position. I can't get like bases, so the only tool we have is logarithm. Since our base is E, let's use the natural logarithm of both sides. So we get the natural log of 0.5 equals the natural log of E to the 19.225 R. Since on the right-hand side, the base of our logarithm is the same as the base of our argument, it's going to equal just the exponent, 19.225R. equals the natural log of 0.5. And now we want to get the rate by itself. So we divide both sides by 19.225. We get the natural log of 0.5 divided by 19.225. And when we put that in our calculator, we get approximately a negative 0.036. Remember, it's decay, it's getting smaller, so our rate is going to be negative. But we're not done. They asked for the equation. So the generic equation would be A of t equals 100 times e to the negative 0.036 t. Sometimes they ask you to put in the exact. In other words, don't change it to the decimal. In case you have a homework question that does that, you would just write A of t equals 100 e to the, and in parentheses, put the natural log of 0.5 divided by the 19.225 times t. But most of the time, they will tell you how much to round it. So using that equation, part B is asking us how much carbon-10 is left after 38.45 seconds. We need to put that in for our t. We want to know the amount when our time is 38.45 seconds. So that would give us 100 times e to the negative 0.036 times 38.45. When we put all of that into our calculator, we get approximately 25 grams. All right, so now we're taking a look at part C, where they're asking us how long does it take for the 100-gram sample to decay to 5 grams? Notice in this question, they're still giving us the same initial value, but this time they're giving us also how much they want to have at the end. So they're asking us to find t. So remember our original formula again was A of t equals 100 e to the negative 0.036 t. So they're giving us 5 grams as our output. So let's solve for our t. We're going to divide both sides by 100, which gives us a 0.05 equals e to the negative 0.036 t. And again, we're solving for that t. It's in the exponent position. Our base of that exponent is e, so we're going to use the natural log of both sides so that it would simplify easier. So natural log of 0.05 equals the natural log of e to the negative 0.036 t. The right-hand side simplifies just to the exponent. Negative 0.036 t equals the natural log of 0.05. And when we divide both sides by the coefficient of t, we get t equals the natural log of 0.05 divided by a negative 0.036, which means t is approximately 83.09 seconds. That's it. If you have any questions, you know where to find me. Thanks, everybody. Bye.